The third question says, how are polynomials represented in computers, and write an algorithm or flowchart to evaluate the polynomial. And I've written the equation of the polynomial here, of which we have to evaluate it. So now in the algorithm steps, first we'll have to start the algorithm. Second, we have to read x and n, all the values of x from here and the values of n from here, all these values. Third, for I is equals to 0 to n, the n will be the one in which we have seen in step 2. We have to read all the ai, that is all the values of a here, all these values we have to read, and then we have to, and then the loop is ended, and we have to store all these values in p, which is the polynomial essentially. Now we have to start a loop again, that is for n is equals to, for I is equals to n to 1, and then we have to evaluate, for example in this whole thing we have evaluated the first term. Now to evaluate the second term, we will have to check the value, which will be the value of a of n to be evaluated here, and then we will get p of a I minus 1. A of I is taken from here, and then it is I minus 1 is evaluated to take the values, to put the value here, plus x of p, the polynomial which was here. For example, this was the polynomial p, there is the value of a n that was stored here, is multiplied into x, and then this for loop is ended, and then we have to write the polynomial, because essentially if the value is not complete, it will go back to again reading all these values till the entire polynomial is evaluated. We have to write p, and then 2 of the question, same question, we have to divide the given polynomial by x minus r, where r is the original root of the polynomial, and we can do this by long division method, which will go something like this, that is a n x of n. We have to write the whole polynomial. So the first term that will be will be a n x of n minus 1. So this will give us a n x raised to the power n minus r of a n x raised to the power n minus 1. Here, from here, the r will be an extra point. So this will be eliminated, and we will get a of n minus 1 plus r of a of n into a raised to the power n minus 1 plus a raised to the power a of n minus 2 x raised to the power n minus 2. Now we will need another term. Another term will be a of n minus 1 plus r a of n, pardon me, a n minus r of n, which will be taken from here to eliminate all the values that are present here, will be taken, and we put this term out here, which will, when multiplied by x r, will give us a of n minus 1 plus r a of n into x raised to the power n minus 1 minus of r a of n minus 1 plus r a of n multiplied by x raised to the power n minus 2. X raised to the power n minus 2 will come here, r of a minus n will be r multiplied by this, and this value when multiplied by this will give us this, which will be conveniently cancelled out. This value will be cancelled out, and we will be left with a of n minus 2 plus r of a of n minus 1 plus r a of n, which will be further into x raised to the power n minus 2, and this will go on and on and on. So to reduce this, we will use this equation, that is we can reduce this polynomial by just writing it in this way, that is b of n minus 1 x raised to the power n minus 1 plus b of n minus 2 x raised to the power n minus 2 plus, that is all the terms of the polynomial will be written, and instead of a, like another coefficient will be written instead of a, but the values of the coefficient will be the same, and then if we equate b of n minus 1 with a of n, then the values will be b of n minus 2 is equals to a of n minus 1 plus r a of n, which will be a of n minus 1 plus r b of n minus 1, and b of n minus 3 will be a of n minus 2 plus r a of n minus 1 plus r a of n, which will be a of n minus 2 plus r b of n minus 2. So these values will continue, that is b of n minus 1 can be written as a of n, b of n minus 2 can be written as a of n plus 1 plus r a of n plus a of n minus 1 plus r b of n minus 1, and all the values can be written like this. So ultimately it will give us b of n minus I plus 1 is equal to a of n minus I plus r b of n minus I, which will be, for example, b of n minus 1, and for example I is 0, so b will be n minus 1, then I will be a of n plus r b of n minus I, where I is 0, so r b of n. So this equation satisfies the whole thing.